I can do a decent job of enlightening you any more than that. Yeah.
How much farther do you think we could see with the next generation of space telescopes to do another experiment?
So this really is my last slide. Drew, down with the lights.
Okay.
Thank you. So here we have the Hubble and the HDF, the Hubble Deep Field, got us back to within about 1.5 billion years of the Big Bang. Okay, looking back in time. The Ultra Deep Field, which was undertaken by my successor, Steve Beckwith, using more sensitive equipment, because we did it with the original WIFPIC 2 camera. It was replaced on the second servicing mission with a much better instrument, better detection levels. So the ultra deep field actually got us down to the so-called HUDF to within 1 billion years. The follow-up that many of you may know about, the infrared sensitive James Webb Space Telescope, which just yesterday had its sun shield successfully deployed in a thermal test. So things are going well with it. Should get us back to about 600 million years. And so that's basically the answer to your question. Interesting, I suppose, follow-up would be, okay, future instruments, how much further do you think we can go? Again, the hot fog starts to get more and more intense as you get back toward the Big Bang, and so it's going to be very difficult from radiation to go back closer to the Big Bang than this. And so one of the really interesting ideas now that is being kicked around is the hot fog does present a problem for radiation. So is there any other thing that we could detect? And the answer may be that gravitational waves are not affected by this. And you have black holes being formed possibly in massive galaxies that are between 0 and 0.6 billion gigayears. And if we can get to the point, hard to think of now, but a century from now, when they increase the detectors of LIGO type things, it may be that it's gravitational radiation that will help us probe closer to the Big Bang than actual radiation. So that's the thinking, yeah. Cool. So it may be that the most important thing to astronomy and astrophysics will end up being gravitational radiation rather than, light, regular electromagnetic radiation.
Right back here.
Go ahead. Yeah.
Dr. Morrison, go ahead.
Okay. You've been talking about things that are very far away, but there are thousands of exoplanets that have been detected. The closest one is around our star, Proxima Centauri. It's only 4 light years away. And there's a planet within the habitable bit of the zone of that planet, which means it's a planet which has water on its surface and is rock. Could you look at something like that? Could you look at that planet, which is the closest planet, and with a telescope and tell me what you see?
In principle, you could. So Hubble Space Telescope has a resolution of not quite 100th of an arc second. Even the closest exoplanet has an angular size that is much too small for us to spatially resolve it. But if you put out an array of telescopes, right, that are separated by much greater distance than the size of the individual telescope, you could do that. And so there are serious proposals to build arrays of telescopes in space that would enable us to do it. And that, like the gravitational radiation, is a long way off, but I think it will be done. But the answer to your question is no. With Hubble, with James Webb, you need a separation that is much larger any individual telescope that we're capable of launching. So the best way of going about it is do what radio astronomers do, right? You create these arrays of individual antennas. And so there have been serious NASA programs that have actually been canceled because they were getting very expensive and results weren't really coming out at a rate that was commensurate with the funding that was required to put space arrays out there. And there's no question in my mind it'll happen, but it's going to be decades from now.
Back here at the door.
Yeah, this may be like a simple question, or it might be a really complicated question. So we know what gravity does. Do we have any idea what gravity is, or why it is? And if space is expanding, what is it expanding into?
We often, in making our mathematical models, deal with the concept of infinity. And it is a very useful, helpful mathematical construct. So if you were to ask me to try to explain or give you a concept for infinity, I can't do it. And so that sounds like an easy answer, but it's a truthful one to your question. What is it expanding into? Don't know, right? Science addresses those things about which we have data, and we don't have data on that. And so I think the best answer is to ask a cosmologist. I'm not saying this to try to get out of answering it, but someone who has developed a philosophy around trying to understand the actual physical equation, mathematical physical equations that lead us to various models. It would be interesting to know what the answer is. In fact, I bet on PBS Nova, there have probably been shows in which Leonard Susskind and others address that question. What's it expanding into? I don't know. I can't tell you. Again, an infinite universe, which it appears to be, that doesn't mean anything to me. You know, I can't grasp that myself.
Let's wrap it up with a question on this side of the room.
This is kind of a crackpot theory that I think about a lot, but since gravity is one of the universal forces of the universe, that's largely unaffected by a lot of things. Actually, it affects a lot of other things. Would you be able to convert gravitational potential energy, just gravitational energy, into other forms of harvestable, like sources of energy? Because if you take two objects in a vacuum,
Sure, conceivably, sure.
it's going to start rotating around each other. Gravity affects everything at once, all the time. So I'm just thinking, well, if everything's always moving, is there like a way to like harness that? Or is that just like nothing?
No,
What do you think?
it's possible. The question is whether or not it's practical.
Yeah, it's probably not.
So it's not crackpot because we know that there is there's transfer of energy between different types of energy. Conversion of kinetic to potential. Well, in any event, again, been a great audience. Thank you so much.